Hi guys. So the lesson today is more about angles, but it's called angle relationships, which deals with different pairs of angles and what we know about their measures. So here we go. Okay, so our first definition is adjacent angles. You may have heard the term adjacent in your just like regular day-to-day life. Adjacent means next to. So if like two classrooms are adjacent to each other, they share a wall, they're next to each other. It's the same idea here. Two angles are adjacent if they have a common side, a common vertex, but no common interior points. So basically they're just next to each other, right up against each other, and that's it. So if you look at angle ABC and angle CBD, those would be adjacent because they share this side and they share this vertex. So let's write that. Angle ABC and angle CBD are adjacent. Okay, the next one is a super important one. Actually, let me go back to adjacent. Angles just being adjacent doesn't tell us anything about their measures. They're just next to each other. That's it. Vertical angles are something that's super important. We will come back to vertical angles all throughout the year. They come up constantly, so it's definitely one to remember. So it's angles whose sides are opposite rays. They share a vertex but no sides. And one thing about vertical angles is they're always congruent. So if you take a look, this angle here, angle DAB, would be vertical to angle CAE, and those would be congruent. And then this one, DAC and BAE would be congruent. So see how they're opposite each other and their sides are opposite rays. They only touch at the vertex. And so I marked them like this because that shows that they're congruent. So it would be that angle DAB and angle CAE. That's one pair of vertical. And then angle DAC and angle BAE. So these are vertical. And they're always equal in measure. Okay, next is complementary angles. Complementary angles are angles that have a sum of 90 degrees. So they add to 90. They don't have to be next to each other. They don't have to be adjacent. This is what they would look like if they were adjacent, and this is what they look like if they're not adjacent. They don't have to be adjacent in order to be complementary. They just have to add to 90. One angle is called the complement of the other. So if I asked you like, what's the complement of a 40-degree angle? You would say it's a 50-degree angle because 90 minus 40 is 50. That's complementary. Supplementary is two angles that add to 180. Supplementary comes up a lot more than complementary, I would say. So definitely one to remember. Again, these are all good note cards. If you are doing the note card thing, each one of these would be a great one. And then again, just like complementary, supplementary don't have to be next to each other, but they can be. So they could be next to each other like this, or they could be, separated like that. You wouldn't really see too much, but you could have a picture that has like, say, 20 angles in it, and any two that add to 180 would be considered supplementary. Lastly is a linear pair. So a linear pair is a more specific version of supplementary angles. Linear pairs are supplementary angles basically that are next to each other. They are adjacent. They have to be adjacent. They make a straight line. That's why I like linear pair line. This is what a linear pair looks like. So these two angles are a linear pair. See how they make a straight line. Whoops. See how they make this straight line here. They add to 180. That would be a linear pair. So all these terms are super important. They all kind of come up a lot, you'll see. I'm going to do a few examples, just naming them, and then I'll do a couple algebraic examples. So the first one, name two acute vertical angles. So vertical angles that are less than 90. So that would be this one here and this one here. So that's going to be angle E. If you want to try these on your own, maybe pause the video and give it a try. So it's going to be EKH and angle FKG. Notice my notation. I have angle symbols, capital letters, super important. Name two obtuse vertical angles. So obtuse vertical angles bigger than 90, that would be like EKF. And HKG. Whoops, I forgot my angle symbol. See, just after I said my angle symbol, I had my angle symbols. All right, HKG. Okay, a linear pair. So remember, linear pair makes a straight line, adds to 180. So and trace any straight line, and then any two angles that make up that line. So see, like this one and this one and this one be considered a linear pair because together they make 180. So that would be angle HKE and angle EKF would be a linear pair. Okay, two acute adjacent angles. So two angles that are less than 90 that are next to each other. So here's one right here that's definitely less than 90, and then see this one right next to it, also less than 90. So that would be acute adjacent angles. Angle JKG and angle FKG. Next one, an angle complementary to EKH. So this is kind of tricky. If you look at the picture, a lot of times kids always want to say these two are complementary, but really the answer is none here. In geometry, you can't assume anything. So I can't assume that this is a 90-degree angle. Although it looks like it could be close to it, I can't assume that it is. I would have to be told that it would be marked like that if it was a right angle. So because I don't know, I can't say that any of them are complementary. So we're going to say none. Oh, actually, I just realized this specifically said an angle complementary to EKH. EKH, yeah. Still, same thing. There's not enough information to determine that. Okay, next one, an angle supplementary to FKG. So FKG is here. So we can find one that makes a linear pair with FKG. So if we were to extend this line this way, this one would make a linear pair with FKG. So that would be EKF. Okay, and then the last one, it says if EKH is 78 degrees, so I'm going to label 78 degrees. It wants us to find this one and this one. So first of all, the one across from it, this one, FKG, those are vertical angles. So EKH and FKG are vertical, making them congruent. So this one would be 78. And then to find EKF, these two here are a linear pair, EKH and EKF. So if I do 180 minus 78, that would give me 102, and that would be this one, EKF, because they make a linear pair. So down here, FKG was 78 because they were vertical. And then this one here was 102 because they are a linear pair and they add to 180. So that's just some basic naming practice with the terms. These last two are some more algebraic examples, and these are more like the ones you're going to do for your practice. So something like letter A, notice we're given 4 angles. Some have Y's, some have X's. So what you want to do is you want to look at the ones that have the same variables and ask yourself, do they have a relationship? Like, are they vertical? Are they a linear pair? Are they complementary? Are they supplementary? Whatever. So again, you're looking for the ones with the same variables. So see how this one and this one have the same variable? They both have a Y. And what kind of angles are those? Those are vertical. So that means they're equal. So I could set up 9y minus 7 equals 6y plus 44. And then solve for y. So subtract 6y from both sides, add 7, divide by 3. So y is 17. Okay, let's look at the x's. Same thing with the x's. They're opposite each other. They're vertical, which is also equal. So again, we're going to set those equal to each other. So we're going to have 9x minus 2 equals 5x plus 14. and solve for x. I'm going to subtract 5x from both sides, add 2, so x is 4. So that's a straightforward one where you can set up one equation for y and one equation for x, depending on the relationship. So let's compare this one to this next one. Now remember in this first example, I said, look at the angles that have the same variable. So like, remember these two had y, these two just had x, so I could set up an equation and solve. Now this one is a little different because you can't really do that. Notice like, okay, I could say, yeah, these are vertical, but what do? I'm going to have 8x equals 2x plus 4y. I have too many variables, right? Or I could say, these two make a linear pair, right? They add to 180. But wait, I'm going to have an x and a y still, an x and a y. Okay, let me try something else. What about these two? These two are a linear pair, right? Those add to 180. But again, there's an x and a y in the same equation. So anytime you're trying to write an equation for a picture, and every single equation that you come up with has more than one variable, that's how you know you have to write a system of equations. So let's write that down. Write a system of equations. Okay, so basically what you want to do is there are three relationships that I just talked about. We could use the vertical angles. So one of your equations could be 8x equals 2x plus 4y. You could use these two, add them to 180, or you could use these two, add them to 180. It doesn't matter which ones you choose, but you have to just write two equations. So you need two equations. I'm going to do the two that are 180 because they'll be set up already for for elimination. So I'm going to use these two adding to 180. And then I'm going to use these two adding to 180. So then the second equation is 4x plus 7y plus 2x plus 4y equals 180. And so then what we have to do is we have to combine like terms for both of them. And then we're going to solve by elimination because they're kind of set up for that. You have your x's and y's on the same side. You have a constant on the other side. So let's do that. I'm going to switch to one color for both of them. Okay, so 8x and 4x, that's going to be 12x plus 7y equals 180. And then over here, we'd have 4x and 2x is 6x plus 11y equals 180. Okay, so that's our system, and now we're going to solve by elimination. So remember, for elimination, you want to look at the coefficients of the variables and see if you can get them to be the same number but opposite signs. So I notice here 12 and 6 would be pretty easy. If I multiplied this entire equation by -2, I would get -12x, and then if I added those two together, they would cancel, and that's your goal for elimination. So then I'm going to multiply -2 by all of these. So this one would be -22y. And then -360. Now what we're going to do is we're going to add together this one that I just created with this one. So these two get added together. So now I have 12x and -12x is 0. So those are gone. Now I have 7y and -22y would be -15y. And then 180 and -360 would be -180. And then if I divide by -15, I get y is 12. When you're solving a system, once you get one of the variables, to get the other one, you just take it and plug it into any of the equations. It doesn't matter. So I'll choose this first one, I guess. I'll do it over here. So I'm going to have 12x plus 7, and then in parentheses 12 equals 180. So that's 12x plus, oops. 12x plus 84 equals 180. Subtract 84. So that's 12x equals 96. Don't fail on me now, stylus. X equals 8. There we go. Very messy at the end, but my stylus is starting to die. Okay, so that's how you would solve one where it's a system. And again, you know that it needs to be a system when any equation that you set up has x's and y's in it, and you can't get around it. So our final answer was that x was 8. That's not going to work. And y was 12. Okay, beautiful. Okay, so let me know if you guys have any questions. I am happy to help on any of these. All right, have a great day.